All right, we're in business. 5 minute lessons are on. Uh-oh. All right, 5 minute lessons. And we're off. I'm going to do as fast as I can, but this is great stuff. The difference between velocity and angular velocity. Well, how do we measure velocity? That could be miles per hour. That's the most popular one. Or maybe feet per second, or meters per second, or kilometers per hour. It's straight lines over time. This would be degrees per second or radians per hour. This is talking about rotational measurement in an amount of time. If I told you that, um, you know, I spun around 720 degrees, you would know I made two rotations. If I told you, well, I'm just going to leave it at that. So this is the beginning. Okay, now the thing you got to, this is the most important thing about the way I'm going to suggest you guys do these because it will require you to memorize nothing. And this is such an important skill in organic chemistry, intro to engineering, physics, like a lot of the best science courses. And it's called dimensional analysis. So if I'm going 60 miles per hour, how fast am I going in feet per second? Well, here's how you do that. Okay. Well, we want to have feet on top and seconds on the bottom. So just get rid of hours. There are 60 minutes in, oh shoot, I just did it upside down. You can see my mistake there. In 1 hour, there are 60 minutes. Okay, so look, now we're in miles per minute. We're close. Well, in 1 minute, there are 60 seconds. Okay, nice. Now, did I just do it again? No. Okay, now we're in miles per second. We want feet per second. So there are 5,280 feet. If you have a hard time remembering that, remember five tomatoes, five tomatoes in 1 mile. And now look what we got. That, if you just multiply those out, so 60 times 5 tomatoes divided by 60 times 60. So 5280 divided by 60, that's your measurement in feet per second. It's going to be like 88 feet per second. Okay? All right. That's important. Like literally, that's the most important thing I can teach you in this lesson. All right. So here's like a classic example. What's the velocity of the tip of a secondhand clock that has a 2-foot radius? It seems like we're not giving us any information, but they're actually giving you the radial velocity, the rotational velocity. So I know that a second hand takes 60 seconds to complete. Okay, and it doesn't tell us what they want the velocity in. So let's just go feet per second. So right now I'm going to write down we want feet per second. Well, right now what we have is ours is going to go one rotation in 60 in 60 seconds. So right now we have rotations per second. We want feet per second. Oh, well, it gives us the radius, right? So how much is one rotation in terms of feet? Oh, well, one rotation is 2 pi times r feet. And you want to write your units there or else you'll get confused of what's going on. So now rotations cancel. Look at that. We're in feet per second. Will you pop that in your calculator, Monica? 2 times pi times 2 divided by 60. Yeah, I bet. No, I believe you. I believe you. 0.21. Think about what you're saying. That's just that's how many feet that clock travels in a second. It's not going to be that fast. Even though this is a big clock, we're talking about like Big Ben here, outdoor clock for sure, 2-foot radius. Okay, and you are wise to ask, like, is that right? Does that make sense? You should always ask that question.